So in this video, I'm going to demonstrate a couple of items. One of them being really to kind of focus on setting up geometry triggers using a laser tracker. And the second one is when we set the geometry triggers up, we need to have some sense of what direction X, Y, and Z are in order to set these up properly. So I'm going to go ahead and create a coordinate frame on my tabletop. And lots of techniques to go about doing this. We could just simply measure a plane and use the direction of the plane, but I thought, why not go ahead and set this up, probably like I would do out in the field. So I'm going to create a plane, and I'm going to create a couple, I think 3 lines, and I want to project those to my plane as I measure them. So I'm going to just do line 1, line 2, and line 3. That way I can kind of have enough there, probably more than I need to adequately define where our coordinate position's going to be. So I'm going to go ahead and begin just trapping measurements into these, and I'm going to also, because I'm using a tracker, I'm going to go in here and I'm going to set some different properties for these for measurement count. So I'm going to say I want to use 7 points for my plane. And then for my lines, I'm going to go to the properties of that and say I want maybe 3 points per line. And I want to apply that to all the lines. So we'll just say that's going to be our desired measurement count setting. I'm already projecting them to the plane, so I don't really need to worry about that. So I'm going to hit OK. And so now that I have that in place, we'll just start taking some measurements in here. I'll make sure that I'm on the proper reflector. So at this point, I'm going to say let's be in stable points to SA. And I'm going to hit measure. It's going to want me to move, so let me go ahead and then just start taking some points. And that little sound triggered me that I'm now going to be measuring into the lines. So before I do that, I want to make sure that I'm switched over to the proper pulling that I set up using an edge nest or pin nest in this particular case. So I'm going to go ahead and again, using stable point, I'm going to go ahead and begin measuring using our lines. So I'll just start kind of closest to the tracker, and there's your part of the beam. So there's point 1. This line. And we'll pause that. So I'm going to come over and take a look at what I've measured so far. Just the end of my table. And we can do some things. If I want to be a bit more precise, I can grab the midpoint of that line based on these. But I do want to take a look and make sure that these are offsetting the proper direction. So if I look at line 2, I think in that particular case, since I used a pin nest, I can go to my fit settings and kind of at this point tell it, no, I really kind of measured, I think, outside that way, so that my line's really offsetting towards the edge of the table. If I wanted to get a dimension, then I could. Look at this straight down on it and see the same thing. Same thing with my original line. So my properties in here, we'll go to our fit settings and say we measured actually that direction. I think, yes. In here, and the same thing with this one. So from where my tracker was sitting, it looks like that one did go the proper direction. So I've got my offsets pretty nicely for my table. Some things that we can do with the relationships or with our features is if I hit the drop down on these particular things, I can tell it, hey, I want to bisect 2 lines. So in this case, I can just select these 2 and actually get my bisecting line. And if I want my origin point at that intersection, I can just tell it, let's do midpoint of 2 perpendicular lines. So select line 1, line 2, and there's my midpoint. So I'm going to wind up using that for my frame. So let's go ahead, construct the frame. And I'm going to say for my z-axis direction, let's pick our plane. For my x-axis direction, I'm going to pick my line. Now the direction is going to go from point 1 to point 3, so that's kind of important. So for my origin point, I'm just going to select that particular origin point that we have in here. I can name it whatever I want, but I'm just going to go ahead and hit accept at this point. I'll pick our world frame as my nominal, and so what that also enables me to do is if I take a look at world, I can come in and say I actually want to use that new frame. Let's just align that to my world coordinate system, and now we're good to go. So now X means something, Y means something to me. So that is kind of important when we want to set up our geometry triggers. So let's do that. So I want to measure the top of my table, and I want to do it in such a way that I have nice orderly data for cross-section analysis, or perhaps I just simply want to be able to sweep a surface through some constructed B-splines or through groups of points. And geometry triggers is a nice way to organize your data in that fashion. If we want to try to figure out what the shape of some surface that we're wanting to measure is, and we don't have a CAD file, for instance, to that. So let's set up some geometry triggers. So I'm going to go to the instrument interface. I'm going to go to the measurement profile called Geometry Triggered Points, down near the bottom. Geometry Triggered Points. And to set these up, I'm going to go into the parameters for that particular measurement profile. And you'll notice I don't have any geometry triggers set. So these are going to be simply planes that as I pass through, I'll get a measurement. And I can define, is that going to go along the x-axis, the z-axis, or the y-axis, or all of them, and set everything up together. I'm going to have my start trigger be button stable. I'm going to say positive beam break. And then we'll go from there. So let's take a look. So if I left click, that's all I did was simply left click here in geometry triggers, I can now create those planes. So I'm going to add planes. I'm going to use a Cartesian format instead of cylindrical. I'm not measuring a tube or anything like that. If I had planes already set up in SA, like along a B-spline, I could pick these, if they weren't going in a straight direction. But in this case, it's pretty square. So I'm going to pick Cartesian. And instead of the z-axis direction, I'm going to say, let's start next. Let's start at 2 inches. So 2 inches out from my origin. I'm going to stop at 30. Or I'll start running into junk that I have stored on my table. And I'm going to say, let's do a spacing every 2 inches. I think that's reasonable for what we're doing here. And I'm going to interpolate the data. In other words, as the as the tracker senses the SMR going into the plane and exiting the plane, it's going to figure out where that point is as it passed through the plane. If I do closest point, it's just simply going to take the closest point to the plane. Some might be before and some might be after going through the plane. So in this case, I'm going to do interpolate. Check that as well. Now I can either draw these in SA or not. It really doesn't matter. But I think for purposes of what you'll see what's really happening, we'll go ahead and draw them. We can delete them later. But when I click OK, these are the geometry triggered planes. So as the SMR passes through these, I'm going to get measurements. So I think for this case, let's just not show, my lines in here. And I'm going to save my geometry triggered points. I'm going to go ahead and close this profile. I'm not going to worry about the group name because it's actually going to take these planes, and that's going to be my point name grouping. I'm going to get out of my pin nest and say I'm going to just use the SMR. We find the reflector first. So we have a reflector. I'm just going to now simply hit measured with geometry triggered points, the proper reflector selected. And so now it's going to wait for me to move. So I'm going to start off in my position with the SMR on the table before I get to these planes. Now it's measuring. And so now as I measure, it could be simply scrub the surface back and forth. All right, I think that's enough. So let's take a look at what we got after doing that. So if I take a look at this, I'm going to go ahead and let's just hide all these planes as well, so we can kind of see what's going on. You see we have our data structured very nicely. And so from here I can just go to each one of these groups, go to the group menu, and if I wanted to fit geometry, I could fit a line or a circle, whatever features. If I'm measuring a pipe, for instance, it would allow me to kind of structure my data so that I could analyze maybe circularity by building circles in a set region, or I can just simply come in and then use this for further engineering down the road. If I wanted to create some surfaces, we could certainly do that as well. So surfaces from objects, so point groups. So if I were to pick from here, just start picking these point groups. And tell it use closest neighbors, ignore points that were within 1,000. For this case, I'm going to span any gaps. I could do some more controls in here, but let's just say it's going to be an open surface as we go. So let's click and see what happens when I hit OK. Let me shade it so we can see what was done. And there's our surface, tabletop surface. So that's just one of the applications that you might want to have for B-splines. For some GD&T checks where having your data structured, profile of a line, for instance, where you're going to want your data structured very tightly like that, so you know for sure that you've got enough data points to adequately perform that kind of analysis. But anyway, hope this has been helpful, and it's again not too difficult to set up, and have fun. We appreciate you using SA.